This time, I'm going to talk about principal component analysis in Python. So what is principal component analysis? Principal component analysis is a linear dimensionality reduction technique that can be utilized for extracting information from a high-dimensional space by projecting it into a lower dimensional subspace. There are so many videos, papers, articles about principal component analysis on the internet. I found this paper written by Stephen M. Holland, and I think this paper is very good. If you are interested in this paper, you can download it and read it. And also, this paper is pretty new. Now, let's look at an example. For example, we have two variables. One variable is width, another variable is length. From this graph, you can see those two variables, they are related with each other. And if we transform those data to this second graph, you can see the first axis and second axis, we can manage to let those new variables to be independent. In reality, we might have many variables. Say we have 30 original variables. But with the principal component analysis, maybe we can only use 2 or 3 meaningful axes to explain our result. That is, we build our principal components. When we calculate our principal components, for example, the first principal component is given by the linear combination of the variable x1 to xp. That is, we keep all our original variables, but we transform them into this new principal component. In my previous video, I used debt to GTP ratio SP500 and other totally 6 independent variables tried to predict dependent variable GDP. In this video, I'm going to use the same dataset. In my previous video, I showed you originally we had 6 independent variables, and after we analyzed the multicollinearity, we found out there are 2 independent variables, x5 and x6. They have very strong collinearity with other variables. So in that video, we just got rid of those 2 variables and build our model with only 4 independent variables. With the principal component analysis, it works different way. From the beginning, we also have 6 independent variables. With the principal component analysis, instead of getting rid of 1 or more independent variables in our analysis, we convert them into principal component. In this case, we convert them to component 1, component 2, and component 3. And then we try to use all those principal components to predict our dependent variable. Now let's see how do we implement principal component analysis in Python. First, we need to load the data. We load our dependent variable GDP along with all those independent variables in Python. Then let's check our original data. You can see all those independent variables. They are all in different scales. For example, the S&P 500 is around 1,000, but the inflation is about 0.1 or even smaller. In order to perform principal component analysis, we need to standardize the scale, all those variables. You can see after we call this fit transform function, all the independent variables transform to similar scale, like this. And then we can call the function to perform the principal component analysis. Here we got the contribution from all those components. This is the result we got from the Python calculation. The first component contributes 65% of the explanation of our model, and the second component contributes about 17%. So if we sum up the contribution of component 1 and component 2, we can have 82% explained by the model. How about we include component 3? If we include all those 3 components, we can have about 74% explained by the model. So it depends on how accurate you want to predict your dependent variable. You can include, say, 3 components or 4 components. For me, I think if you include 4 components, it will explain over 98%. So that's good enough. This is how I perform principal component analysis in Python. Please provide your comments and subscribe to my channel. Thank you very much for watching.